For this month's update, I thought I would introduce you to a friend of mine. This friend has been working on monitoring ground deformation in the Yellowstone region for decades and is so good that they can detect millimeters per year of change, tiny, tiny change. So I'm really pleased to introduce you to my good friend, the continuous GPS station. This kind of instrument, it's very well coupled to the ground. It's receiving satellite signals, so it can detect how the ground is moving to a really, really small detail. And there's dozens of stations like this throughout the whole region. It's been detecting since 2015 that the ground has been going down by about 3 centimeters or so per year, about an inch per year. But prior to that, for a few years, the ground was going up. For a few years before that, the ground was going down. So it's instruments like this that can show us that the ground in Yellowstone almost looks like it's breathing, always moving at about an inch or so per year, never really fast motions, not something you can see, but something that, thanks to my friend here, we can detect really well. And if you're interested in seeing data from all these sites, it's all on the monitoring map on the Yellowstone Volcano Observatory website, so you can check it out for yourself anytime you like. Well, speaking of data, why don't we look back on the month that was and check out seismicity, ground deformation, and geyser activity that occurred over the course of the past month.
It was another average month for earthquake activity in the Yellowstone region. The University of Utah located 100 events during the month of January, the largest a magnitude 2.6 off near Hebgen Lake. Most seismicity in the region occurs in this band between Hebgen Lake and the north central part of the park, so nothing new in that respect. A couple of small swarms, that's also nothing new because about half of all seismicity in the Yellowstone region occurs as part of small swarms of earthquakes. Turning now to ground deformation, this is vertical deformation at the Lake GPS site on the east side of the caldera. The plot spans the last 2 years. Each blue dot is 1 day of data. Downward trends indicate subsidence and upward trends indicate uplift. The caldera has been overall subsiding since 2015, but that's interrupted in the summer months by a little bit of uplift, and that's caused by changes in groundwater and runoff conditions. That same transition happened in 2025, but it lasted a bit longer than usual. Normally that ends, as you can see in 2024, around September or October. This lasted until late December before finally turning around, so back to subsidence of the caldera. This site is near Madison Junction, P711, and it's showing horizontal motion in the east direction. So positive changes are motion to the east, and negative changes are motion to the west. In July of 2025, this site started moving to the west, and that's due to a small amount of uplift, a couple of centimeters or so, that began in July of 2025 on the North Caldera Rim, just to the south of Norris Geyser Basin. So that small amount of uplift continues through January. We unfortunately don't have any thermal data from Steamboat Geyser. There's no indication of any real activity there, though, after the December 31st eruption. Looking at Black Diamond Pool, that was the site of a hydrothermal explosion in 2024. There were 2 eruptions from the pool in January, one on January 19th and one on January 24th. Unfortunately, we don't have any video of the pool because one of those events occurred when it was dark out and the other when the camera was covered in ice. But eruptions do continue from Black Diamond.
That does it for the monthly update for the Yellowstone Volcano Observatory. Now remember, if you have any questions at all for me or for my friend here, you can email us at ybowebteam, all one word, at usgs.gov. Until next month, stay safe, stay healthy. See you next time. Bye-bye.